answer Dirk's suggestion on the subject, trying to tell the story of what was our dream at the laboratory for agent-based social simulation in what we wanted to do with agents. And that starts with a general introduction. Most of you people know agent-based simulation quite well, but I have at least to show three things. This one is one of my favorite and not so often shown, which is St. Thomas in one of the questions on potentia, on power. And if you've noticed my questions, power is always one of of the questions that I ask at seminars. Do we have enough power to do something or not to do something? This is scholastic reasoning, so it's extremely complicated. I've also put the Latin version there. And if you read carefully, it doesn't really say what I wanted him to say, but I can't twist Thomas more than that. But there is this sentence that not it subsists besides individuals in the genus of substance, which kind of means that modeling reality, well, reality is made of individuals, and so you have to start from there. I think we could also go to Plato, but this is a good starting point for the idea. And then the inspiration that our specific group had, essentially this inspiration as the starting point. This is Axelrod, and most of you have not know his tournament on the prisoner's dilemma, but also he was stating this very boldly in years in which complexity was still something discussed. We had a presentation on complexity from Guido, and he focused on the network part, but I'm very fond of the systems that are more than the sum of their parts, and all this group of people were working on this, and Axelrod was as bold as proposing that simulation as a third research methodology, distinct from induction and deduction. It's not that useful now today, this kind of approach. We're, as I will say also later, we're in a kind of agents as normal science. We kind of got there, at least that's my opinion, and that's my answer to Dirk's call. At that time, we were trying to make it show something as something exceptional. And that's something that's happening now. So if you want to see where we're going, that's another key question and another important part of our approach, which is you can't explain it if you're not growing it. And we already had the Mayan astronomers, Feynman's example here, but there's plenty more. I mean, a discussion that's really very actual today is a machine that can answer the Turing test, and we got there. Does really explain how we think or not? It's reasonable to say not, even if I'm not, I'm very optimistic on the future of AI. I'm not one of those persons that say that they don't have conscience or they don't have creativity. I totally think they have creativity, or we don't. But that this is not a good, this is not the same as saying that they can explain. So Epstein is doing a lot of promotion of this approach for agents, and it's a kind of new architecture which is psychologically inspired with strong foundation on how the brain works in some situations. In the end, the system is really, really simple and can be expressed in mathematical forms, which seems to be a strong requirement for the author, for Epstein himself. I find it really, really simple in which, in the end, you gather a series of inputs, and then you have a threshold which is mostly fueled by strong emotions, fear, the first one. And this threshold, if you go over that threshold, the agent takes action, otherwise it doesn't. That's the base of this approach. So for those of you who knew Rosaria, and Rosaria's dream was simulations with the agent's mind. So complexity in the agent, as well as complexity in the society and in the rest of the story. We had we tried hard to go in that direction, modeling not only the interactions between agents. What makes an agent-based system complex is the level of interactions. If you don't have interaction, the agents sum up essentially in a linear way, and there's no real need to do all the apparatus. So if you model the internal cognitive processes, you're having something more than basic agent-based simulation. You're having a kind of representation in the minds. And at that time, we had a series of approaches which tried to deal with what we call the cognitive artifacts. Having a cognitive artifact means that you have an explicit representation of some concept that we think exists in a mind. That's not a neural network representation. That's an explicit representation of something and can be employed with a full-fledged logical system behind it, or in some kind of approximate form. We focused on some specific kinds of cognitive artifacts, mostly reputation and norms, and that's something that the group is still working on quite a lot. Trust also is mentioned in there. So simulation as the interaction between a model of the mind and a model of society, and then the idea of emergence and emergence. Emergence, I mean, we're all complexity experts here, so we know what it means. It is another side of this idea that the system is more than the sum of its parts. But emergence was a term coined by Castelfranchi to describe what happens when the representation of the agents represents the world in its mind and then acts on the world, causing a loop in the causal system. So that's something that molecules won't do, but agents will do. We were just discussing traffic. I mean, I was wondering if there was some adversarial, where is Stefan? Adversarial attack to the system, and well, I couldn't think that you could. One of the things that they examined is that you can simulate, try to be a bus, because you have built a kind of bus transponder very easily. So you have to, if you do a modular system with humans, you have to expect that humans will game the system for their own profit. It's irresistible. So that if you put that in the simulation, then you have an emergent, what we call an emergent level. The most famous approaches of this kind, apart from ours that was mostly explicit representation, you will see an example later, are the BDI approach or the DBO approach. I'm not going in detail into that. I've run a few simulations with BDI using JSON, which is a platform developed in Brazil, and also studied Desire, which was the original platform developed. But reality is that this system grows out of control very, very fast. Let's get to my favorite example developed with Jordi Sabater and Rosaria. We try to model, this is a JAST paper, an explicit representation of the path that reputation information follows into the mind. So we had, this was a very old system, and it has also been re-implemented by Brazilian researchers, but we had an original implementation in Java made by Jordi. And you could follow the activation of those concepts as they enter the mind and go up in the level. No time to get into details, but this was kind of new for the time, and we found it cool. And then the reality. Why I have this skip between the dream and the reality like now here? Because those things that we tried to do were always a bit too complicated to get into production and to get more. I mean, we got some good papers. We didn't get into Nature, but we were relevant in our community. There was always this temptation, the need, a force that says you have to simplify this. And of course, you can also run things with simple agents. So I'm bringing here another example, which was inspired by our collaboration with several groups, including Bicocca Milano and University of Jerusalem, and inspired by this paper by Groff that stated these are I mean, if you open an agent-based paper at random, then there is this introduction written in one way or the other, and AI could write it perfectly now because it's been read and discussed very, very times. You can replace crime with most social events that you want. But this was published in a crime journal, and then people wanted to do those things. So unfortunately, the slide has cut my other two citations, but we did this kind of work with the expert of the fields, and it was a nice project. We did a lot of work with stakeholders. We spoke with judges, and we spoke with police on anecdotally, the judges couldn't really understand what we wanted to do. The police could, and it was a really nice interaction. And we got a couple of models. I'm just showing you ideas. This is the model about crime. The trick to make it feasible is to focus that we focused on recruitment only. This removed a lot of complexity and made the model feasible. But still, this is a model which asks a lot in the setup because we wanted to have plausible levels of representation of families, employment, friendship, and on top of that, the criminal activities. So it was multiplexed and carefully calibrated. When I had to do this, it kind of started my interest in artificial populations that I'm kind of following now. It's difficult to do this thing. And if I had to look at it now, how we did it, probably there are some parts that are not plausible, but it was a good exercise to put them together. This is the recruitment. We had two models, one focused on crime and one on terrorism, both on the recruitment phase. This is just to show you mostly, I mean, and this line, and they're not all, and there are too many. Even if we try to calibrate the essential things as well as possible. That's the good part, I think, because this was the result of the interaction with stakeholders. And they kind of knew those weights, because for each of these items, let's take, for example, the criminal history of a person, they ran a meta-analysis on a published paper, and they gave us a number. They said, okay, for your propensity to be recruited or commit a crime, in this case, be recruited, the criminal history has a weight, and this is the number. That's really good when you have this problem of excessive dimensionalities in the agent systems. And it was, I think, one of the best thing that came out of the project. It was impossible to convince them not to play with this as a threshold. And we're back to agent 0. In the end, those agents don't have a complicated mind. They run with a threshold. And that's why I call this the reality. In the end, when you get with the stakeholder in a realistic problem, you're forced to simplify your agents. While if you're studying things theoretically, you still have that kind of freedom. This is the result. And it looks like, I mean, data from the real world, but it's just simulated data. And I'm not discussing it, but you can kind of see the things that worked because they are the significant ones. So if you see a star, that's it. So employment worked. And also we had these 3 dimensions. These are opinions the agents are discussing about. So this is inside the mind of the agents. It was simple, but not that simple. These agents had explicit representation that ran an opinion dynamic systems of those 3 items because the meta-analysis showed that these 3 dimensions were the relevant ones. What are the results for these 3 simulations? And we couldn't use our models of the mind, and we had a lot of work with the stakeholders. We did a big model. It was a lot of efforts. Are those results reliable? Are they being used right now? I can't write the answer there, but the answer is no. It's pretty obvious that we did it. We are still kind of working on it. The basic idea, the simplest idea are simple enough to communicate. They tried a set of strategies to reduce recruitment. And I mean, giving those people employment was the only one that worked. perhaps we didn't need all that apparatus. I mean, if we have all this apparatus now and nobody's using it, we're doing something wrong. So that's why this part is the reality. We're still stuck somewhere. Back to the reality, and this is the part that I mentioned before. Are agents around here? Well, from this conference, I think that I had the real impression that agents are normal right now in the community. We've seen a lot of agent-based models, and people didn't feel the need to explain what they are. So there wasn't that slide saying agent-based model are good. Okay, we did an agent, we did it like that, and then let's focus on important things. That's very good for me. So they have models of epidemics, traffics, other models, and we have this kind of approach. It works. So we have good models. What we're still lacking? Okay, for my model, space data exploration, we didn't run enough. The mines, we didn't get there. And replication, that's what burns me more, maybe, that we don't reuse enough the other people's work. So space data exploration, okay, you all know that. I really liked Alessandro's statement, very curtain net. His models have 2 or 3 parameters. So he solved it. He solved it because he has all the data and he only tells you what happens tomorrow. He doesn't tell you what happens in the long run, and but he runs the model every day. That also was very important. So it's tomorrow, but you have a lot of these predictions. But how do we move? If you want to move forward from the baseline of here and now, and my people, the stakeholders, wanted these models to run for one is 6 months, but the other is 30 years. The first time that I ran the model, because I had the accurate demographics, I had the population extinction and didn't notice. Because in 30 years, it was a city in Italy, and people, we are so old now that in 30 years, like the final population was 1/3 of the initial, and I looked at the results, they were so strange. What's happening here? We're not used to run for that kind of time. And also and this also, Alessandro has in a situation in which, or weather prediction, it's difficult to think that a storm can go in one direction or with 10% in the probability in the opposite direction. But if you have reactive agents, if you have emergence, what happens to if you have large models, what happens to the incompatible trajectories? And what if the set of data is changing under your eyes? People, I mean, think of what's happening in the United States right now. People's behavior is becoming less and less predictable. Mines, well, we don't have emergence right now. Let me check the time. I think I'm kind of on time. And replication, as I was telling before, that's the things that burns me more. And I think that really we live in the wrong set of incentives for that. And that's connected by from several things. I think Alessandro also mentioned, this is from Alessandro's slide, Mob's lab, move from single teamwork to coordination. And the other thing that I really don't like is the paper as the unit of measure of our existence. And Dirk tried to work on that. We had this innovation accelerator, and we kind of tried, but in the end, the system is rigged in such a way that we always go back to the same place, because even those of us which are ending their career and could just stop publishing, but what about your PhDs? If you don't teach them the rules of the game, you're burning them, and then they will go nowhere. So we are immersed in a culture of competition within the rules of the system. This is, I'm citing you, Dirk, capitalism and science believe in the competition of idea, yet, I mean, science was supposed to be this thing. The Mertonian norms of science, just from Wikipedia. I mean, there are 4 norms of science which say several things. Many of them are obvious, like organized skepticism. We don't just believe it because someone said that. Disinterestedness, with research for the purpose of research. Universalism, but also communism. Science should have common ownership of scientific goods to promote collective collaboration. That's not so obvious not obvious at all in the current moment, but this was something that in a certain set of values, in a certain historical period, because if you read Hobsbawm, for example, you understand that the way we conceptualize science is due to the explosion of science after the Second World War. So are we walking in the right directions? These are the things that we should explore together. Democracy issues, we don't have a good simulation or a good group of people working on simulation. Regula's presentation was really touched me from this point of view. She mentioned the issues of pressure of the market and minority domain. What about conflict and explicit adversarial behavior? The people trying to be a truck with a transponder. Digital twins, they're just kind of turning the things around, giving new names. And we should always remember that this very good sentence, also from Regula's presentation, there is a lack of normative justification of the current realities. I think we can remove normative. We believe in some set of things, and we perpetuate, we recreate it with our actions. So that's the end, and the reality and the dream. We are getting there. I really think this is good news. Agents are working. We're not working together. We are not mixing our algorithms, because those simulations, I mean, already parameter exploration is a nightmare. But if you start to think that people could change the algorithm, and sometimes you hide so much information when the programmer or the junior member of the group decides how to do things, especially if you're working with NetLogo or things like that, much less if you're doing game theory. But then game theory, I mean, has another set of issues. So that's it. That's the current situation and my dream, and the rest. Something that could be good is working together on some kind of infrastructure. But that's something that I'm doing in another field. It kind of works, but requires strong incentives. So I think that that's the infrastructure I'm working for, and this is financing the work.
Thank you very much. Yeah.